All right, guys, here's one of your worksheets on electric circuit drawing. I'm going to go through some of these problems with you, but the key will be posted. And if you need to go over some of this or you would like clarification, please just come in or shoot me an email. So, label each of the following circuits as series, parallel, or both. Label the parts of the circuit. Well, here, guys, we've got a power source that goes along one path. Because it's going along one path, we know that it is going to be a series circuit. Here, a lot of people are going to think that this is indicating that we have a parallel circuit, but there's really no parallels in this. Here we have a series circuit and here we have a series circuit. Notice how there's no overlap, okay? So what's happening is the electron flow is going here, here, and here. So overall, that is also going to be a series circuit. Here, however, we have several different pathways. We start here, we're going around. The electrons can go here, the electrons can go here, the electrons can go all the way around. So we actually have a series circuit and a parallel circuit. So this is an example of both. Same situation here. We're going around, we could go here, we could go here, or we could go all the way around. And because we have all those different options, we've got a parallel circuit, but also a series circuit. So that's both. Same situation here. We're going around. We could go just here, we could go here, or we could go here. And this is why, guys, that those switches being open can really affect which light bulbs are going to be on or off. Here, we've got a circuit. Here we've got a circuit. This circuit could go without this, okay? So that's going to be both as well. Now, many of you guys are going to believe that this is both as well. The difference here is that we can totally block these off. So what we have right here is we have a parallel circuit. All right, I'm going to do a couple of these. I'm going to do number 2 and number 6. So what it's asking is, using the correct symbols, draw a series circuit with a battery, 2 light bulbs, and a resistor and a switch. Show the direction that the current travels. So I want you guys to understand that it doesn't matter where you put the battery. That's just going to be the starting point. So I'm going to mix this up a little bit for you. I'm going to draw a battery, and I'm going to have a positive end, negative end, and a positive end. So the current's going to travel this way, and we need 2 light bulbs. So light bulb, a resistor first. Resistors look like this, okay? And then a switch. It does not tell you whether or not the switch is open or closed. And when I tell you to do that, it doesn't matter then. You can draw it open or you can draw it closed, okay? All right, number 6. Draw a circuit with 2 batteries in a series, 3 light bulbs in parallel, and 3 switches. Each switch should turn 1 light bulb on and off. Show the directions that the current travels. Okay, don't get overwhelmed by this. The first thing that you need to start off with is 2 batteries. Now, you can put 2 batteries right next to each other. You can put them on 2 different areas. So I'm just going to go ahead and draw a positive here and a negative here. And I'm going to have this battery go, and then I'm going to draw another battery. Notice how the positive is here, and it's the closest to the negative, and then the negative, okay? Remember, that current's going to flow along that, and the opposites are going to attract. The same or the like charges are going to repel. So we've got this started. Now what we're going to do is we need to draw 3 light bulbs in parallel. So we've got to draw some parallel circuits. We know we're going to have a light bulb here. We know we're going to have a light bulb here, and we know that we are going to have a light bulb here. We need to have 3 switches, but each switch needs to be able to turn 1 bulb on and off. So if I put a switch here, it would influence all of these. So we need to put a switch right here. We need to put a switch right here. And we need to put a switch right here. Now, if we put them after it, it wouldn't affect all of each and every one of these. So we need to put it before it. So right here, we've got a switch that goes to that, We've got a switch that goes to that light bulb and a switch that goes to that light bulb. And then we just need to draw it as a complete. What is missing? There's an overlap of wires here, so we need to draw and indicate that there is a crossing over of wires, okay? Now, I'm going to go ahead and do a couple of these on the back with you so we can review how you're going to be able to understand whether or not the bulb is on or off, okay? So for this first one, bulb 1 burns out. What's going to happen to all of these if bulb 1 burns out? So if bulb 1 burns out, this current can still go to 2. It can still go to, this current can still go to 2. It can still go to 3 and 4. 1 isn't blocking the main pathway, okay? So it can still go, it's going to go to here, it's going to go to here, and it's going to go to here. Now, just because it's not going to make this one work, this can still go all the way around. This can still go all the way around. So number 2 is going to be on, number 3 is going to be on, and number 4 is going to be on. Now, if bulb 2 burns out, number 1 will still work. Number 2 won't work, but number 3 and 4 will. So all of these are on as well. If bulb number 3 burns out, here's where it gets interesting, okay? If bulb number 3 burns out, we can still go number 1. We can still go number 2. If bulb 3 burns out, though, that means that the current can't go through to 4. So the only exception is 1 is still going to be on, 2 is still going to be on, but 4 is going to be off because 4 has that current that needs to go through 3 to access it. Last but not least, we've got 4. If 4 burns out, it can still go through 1, it can still go through 2, but look, 3 can't complete its circuit, okay? If we had another light bulb after 2 and 2 burnt out, that one wouldn't work, but also if this burnt out, 2 wouldn't work because it has to be able to complete its circuit. If there was a light bulb right here that burnt out, none of these would work because it cannot complete that circuit. So number 1 is still going to be on, number 2 is still going to be on, but number 3 is going to be off. I'm going to go ahead and post the key for this. If you would like to come in and get help, just reach out to me. Thanks, guys.